Hi guys, this is question 13 on the Unit 1 Summer 2019 WJC past paper, and we've been given a curve y equals 1/9 x cubed minus kx plus 5, and we're told point Q lies on C and such that the tangent to C at Q has gradient minus 9. We're told the x coordinate of Q is 3. Okay, so that's a lot to take in. So let's first, we have our x cubed graph of 1/9 x cubed minus kx plus 5. Okay, a curve, and we're told point Q lies on C and it's such that at Q has gradient minus 9 and the x coordinate of Q is 3. Okay, so we're told Q, and Q lies on C, so on this line, and we're told Q has x coordinate 3. We haven't been given the y coordinate, and we're told at this point it has gradient, so gradient equals minus 9. Okay, so what we know when we're dealing with gradient, we know delta y over delta x gives us our gradient. So that's our gradient. So we're told that dy dx should equal minus 9 at Q, and we've been given an x point for Q. So let's take the derivative of our y, of our curve C. So we got dy over dx equals, so what we're going to do is times by the power and then drop the power by 1, so on the x term. So 1/9 times by 3, lots of x squared minus k, because that will just be x to the power 0, and then that will just be 1, so we've just got minus k. Okay, now we can plug in what we know. So we know at Q we have dy dx equals -9 and x equals 3. Okay, so minus 9 equals 1/9 times, sorry, so that's going to be, I should have simplified that. So this is going to be 3 over 9, which is going to give us 1/3 x squared minus k. So that's dy dx. Okay, so we got minus 9 equals 1/3 of 3 squared minus k. And we only have the one unknowns, which is our k, which is great. So now we can just rearrange and solve. So I'm just going to simplify that first. So minus 9 equals 9 over 3, so that's just going to be 3 minus k. So what I can do is I can add 9 and add k to both sides of the equation, and then I'll get k equals 3 plus 9. So we're told k equals 12, which we've been shown, so we were asked to show that k equals 12. Awesome. Okay, so that's as required. So part B, find the coordinates of each of the stationary points of C and determine their nature. Okay, so there's two important parts here. So we need to know what stationary points are. And stationary points are when dy over dx equals 0. So on our curve, we'll have, so I'll just draw a quick x cubed graph. It's probably going to be nothing like what we have, but I'm just going to estimate an x cubed graph. We're going to have something like this, and our stationary points are here. So these are when the gradient equals 0. So these, we have one here and one here. So what we can do is we can look at the derivative and set it equal to 0. So I'm just gonna copy and paste my derivative, saves me right now, and I know it's here. So 1/3 x squared minus k. So here we go. So dy over dx equals 1/3 x squared minus k, and I'm just going to set that equal to 0. And what I should do as well is, we've just found out k equals 12, so I can change that to 12. So 0 equals 1/3 x squared minus 12. Okay, so we only have one unknown again. So what we can do is just rearrange and solve. So I'm going to add 12. So I'm going to add 12 to both sides of this equation, and so I'll get 12 equals 1/3 x squared, and then I'm going to times it by 3. So I'm going to have 36 equals x squared, and then I'm going to root both sides. So I'm going to have the square root of 36, if you don't know, it's 8. You could use a calculator, so it's going to be 8 equals, okay, so I'm going to have x, I'll write it this way, so x equals 6. However, when we square root a number, we're going to have two possible numbers. Both the values are going to be 6, but we're going to have a plus and minus, and this is really important because looking at our graph, we knew we were going to have 2 points. If we had just worked out that was, if we left that as positive 6, we'd still be looking for our second stationary point. So, okay, so I've got two stationary points, and one is at x minus 6. So I'll just put, I'll call it point A, is at minus 6, and I don't know the y yet. And I've got point B, which is at positive 6, and I don't know the y yet either. So I can now use the equation I was initially given, y equals 1/9 x cubed minus kx plus 5. I'm just going to copy and paste that to bring it down. So I can use that now to find my y terms. So my y values, I missed a bracket there. So y equals, I'll write it again with my k as 12, so y equals x cubed minus 12x plus 5. So y equals 1/9 minus 6 cubed minus 12, lots of minus 6 plus 5. Okay, and that gives me, typing that into a calculator, I'm going to have 1/9 minus 6 cubed minus 12, lots of minus 6 plus 5. And that gives me y equals positive 53. So my point A has coordinate minus 6, 53. And that is one of our stationary points. Doing the same again for B, so we could get y equals 1/9, this time positive 6 cubed minus 12, lots of positive 6 minus 5, plus 5, sorry. Okay, plugging that all into a calculator, we get y equals minus 43, and that's our second stationary point. Okay, now we have to evaluate and determine their nature. So what they're asking for here is, when we have our two stationary points, we're either going to have a maximum or minimum, so this or this. And the way we work that out is we have to take the second derivative. So maximum is when we take the second derivative, so d2y over dx squared, and it's a bit backwards, so that is when it's d2y over dx squared, so the maximum point is when d2y over dx squared is less than 0. And then the minimum is when d2y dx squared, just the opposite now, is greater than 0. It's a bit backwards, but there we go. So what I can do is take the second derivative, and I know my derivative, I'm just going to copy and paste it, is here. So that's my first derivative. So second derivative will be d2y over dx squared equals, so times it by the power, reducing the power by 1, so I'm going to have 2/3 x, because my minus 12 will then be nothing, so this disappears. Okay, so cool. So now I just plug in my x values, which one is 6 and minus 6. So when I have 2/3 6, d2y dx squared, that is going to be positive, so I'm going to have, what's that, so 12 over 3, which is just going to give me 4, and I know 4 is greater than 0, so that's my minimum point. And then just doing it again for, so d2y dx squared. So evaluating for minus 6, we're going to have 2/3 minus 6. And this time we're just going to have minus 4. And we know minus 4 is less than 0, so that's going to be our maximum point. Awesome. Okay, so if I write my coordinates out again, so I'll have minus 6, 53, and we know that's the maximum point. And then I've got 6 minus 43. And that's my minimum point. And now what's the last part? Sketch the curve C, clearly labeling the stationary points and the points where the curve crosses the y-axis. Okay, so the first thing I'm going to look at is crossing the y-axis. And we know there's two scenarios when they ask for crossing the axes. So let me just find my y equation, which is here. Okay, so we know if the line crosses the x-axis, so intersects x-axis, so let me intersects, we're looking for y equals 0, but if it intersects y-axis, we're looking for x equals 0. Okay, and we were asked to find intersecting that y-axis, right? Yeah. So that's when x equals 0. So we'll have y equals, this will all become, well, I'll just sub it in. So 1/9 0 cubed minus 12, lots of 0 plus 5. And we can see that this all will be 0, this will all be 0. And so we're just going to have y equals 5. So that's my y-intercept. So it crosses the, as it crosses the y-axis, my x will equal 0. And it will intersect y equals 5. So I'm going to have coordinate 0, 5. Okay, right. So I've got 3 points I want to plot. So minus 653, and I'll say that's about, I'll say minus 6 here, so 6 is about here. I'm going to look at 53, so that's about, let's say it's 53 is about here. Let's look at minus 43, and that's about here, somewhere here. Okay, now plotting our points. So minus 653, so we got point here. We got point by here. And the last point, so x0, y5, where it crosses the y-axis. Yeah, that looks about right. And then I just draw it in. So I'm expecting it to come up. And there we go. And I'll just label my axis so X and Y, and that's my graph I'm expecting. Hi guys, if you found this video useful, please consider liking and subscribing. All written notes will be available in the description. Best of luck with all your exams, and I'll see you in the next one.